All right, so we're going to extend off of evaluating expressions and going into formulas. So going into formulas is pretty much evaluating expressions. There's going to be a slight difference to this. Oops, there we go. So a formula is a mathematical relationship that is expressed as symbols. And you've seen some of these before. Most people have seen quadratic formula before. So x equals minus b plus or minus the square root of b squared minus 4ac divided by 2a. Another one that most of you have seen, this is also another formula. Area of a circle is pi r squared. Another common formula you've probably seen before is Pythagorean's theorem. You know, a squared plus b squared equals c squared. There's plenty of formulas that you would have seen before. One of the things that's a little different here is that it's not just expressions, we got equations here. And what we're really doing is that we're just focusing in on part of that equation. So this part right here would be an expression. But this, where I put the equal sign, that turns this into an equation. So really what's going to come down to is this expression part, the part we're going to evaluate to figure out what x would be equal to. We would evaluate this part of the expression to figure out what a was equal to, and we would evaluate this part of the expression to help us figure out what c squared is equal to. So as I've seen, it's pretty much just evaluating expressions. So one of the things that's also a little different here is that, I'm trying to clear my screen, that these symbols, we don't necessarily have someplace written that a is equal to 2 and b is equal to 3 and c is equal to -5. Like we saw with evaluating expressions, we saw values given. Here, we kind of have to guess what those variables mean a little bit. It's sort of like assume that you know. So for example, these are formulas that I gave you because a lot of your questions have to do with volumes and areas. So this is the volume of a rectangular solid or a cube, or just a box. So if I want the volume of a box, I have V equals LWH. Well, I don't think I have to tell you that V is going to be volume. We know that H would be the height. So this is the part where I'm saying that we're not going to necessarily tell you what VH and WL are. Like, we're not going to write it out. What we'd say is, I know the height is this, I know the width is this. I wouldn't say, I know that H is this or W is this. Okay. Same thing here. If you're looking at the area of a circle, we know that pi is a number, but we also know that r is supposed to represent what's called radius. Right. So be prepared to come back to here. So as an example, we have here that a triangular garden, and we're going to just draw a little picture of it to the side. We have a triangular garden. Trying to get nice things to make nice shapes here. There we go. So we've got a garden like this. It's a nice triangle. We know that the base of the garden, so the base, we just mean this sign on the bottom. So we know that this base is going to be 83 inches. And that we know that the height, so height goes from base to the opposite vertex. So this is going to be the height. And we know that this height here is going to be 75. Okay, but how do I figure out that area? Well, if we go back here, we see area of a rectangle. So we have this rectangle labeled out for us. We have all this stuff labeled, but it's all the same as that I need for that formula for area is 1/2 of base times height. All right. So going back here, notice I never say B is this or H is this. This is that part where I'm saying that we don't necessarily directly give it to you, but we assume that by looking at this, you would probably think that, oh, well, base is probably B. And we're told that that's going to be 83. Height, we probably should assume is that H there, because that would make sense. So H is going to be 75. So if I just want the area of this garden, A is going to be equal to 1/2 of my base of 83 and my height of 75. Okay, so 1/2 times 83 times 75. Okay, I thought it was looking a little too big. I think it's fine. It's 300, or sorry, 3,112.5. The other thing to mention here is that we were measuring in inches. So if we're looking at areas, areas are going to be a unit squared. So for example, you could have feet squared, you could have inches squared, you can have miles squared. You can just, as long as you have a dimension that is squared. So because we were inches and we did area, this is inches squared. Okay, so for your worksheet, you just have 2 questions here. We have, first, this one is, we want to figure out well, we'll just read the question, we'll see what we're figuring out. So you have a Campbell soup can that is 6 inches tall, and we know that the radius, because it's going to have a circular base, we know that radius is 2.5 inches. We want to know how much soup will the Campbell's soup can hold. If you go back here, you can think about what you have. Do I have something here that looks like a can? That's probably what I need to be looking at. Am I looking for an area, or am I looking for a volume if I'm trying to figure out how much soup fits in that can? So that will help you decide, am I looking over here? If I'm looking over here, am I looking at a sphere? Am I looking at this rectangle? Kind of figure that out, and then you can go back and fill in your formula. Same thing here, just to kind of point one thing out. Just to fix this. The Great Pyramid of Giza has a square base of 755.75 feet. So what we mean by the square base is that we mean this is just one side of the square. Which I realized that was a little confusing way I wrote it. So just to kind of let that be a little more obvious, that's just one side of your square base. So one side of the square base is 755.75 feet, and the height is 481.4 feet. What is the volume of the pyramid? So once again, go back to that formula sheet, look for a pyramid. In this case, it's telling you if you're looking for volume or area, and forgot how we fill in the equation. Okay, so we have this Campbell soup can. It's 6 inches tall with a radius of 2.5 inches. We want to know how much soup it's going to hold, so we're looking for volume. So we're literally looking for volume of a can, or instead of a can, we are going to call this a cylinder. So we know we're looking at something that looks like this. So we're told that its height is going to be 6 inches, and that its radius of the circular base of this can, or the top, however you want to look at it, but that radius is going to be 2.5. This is a 6-inch can. This is a big can. All right, so we go back here. So when it says right circular cylinder, it means a cylinder with a circular base that has perpendicular sides to the base. That's all that means, but you're looking for a cylinder. We're looking for the volume, and we see that the volume is going to be, let me move that a little bit. The volume, there we go, is pi r squared 8. So we're assuming that this is radius, this is height. So looking at this formula, we're told that the radius, or our r, should be 2.5. We are told that our height, our h, should be 6. And then pi, so you probably have a pi key on your calculator. The other thing you can do is you can replace this with 3.14, or you can even go out like 3.14159 to Just at least at the very minimum, 3.14, but you could go up further rounding it if you need to, or you can just use your pi key. So if I use my pi key on my calculator, what I'm going to get for volume is I'm going to have pi. I'm going to have 2.5 squared, and then I have a height of 6. Okay. Pi 2.5 squared. If you need to, you can do 2.5 times 2.5 times 6. This is going to be 117.8. I'm just going to round 2 places, 81. And once again, we're doing a volume. So if you didn't know volume, like I said, area is always squared. So volume is going to be a unit cubed. So that'd be like feet cubed, miles cubed. You don't usually see that one, but like feet cubed, miles cubed, inches cubed, centimeters cubed. That's a common one you'll see. So this case, everything was in inches. So this will be in inches cubed. All right, so here we wanted to figure out the volume of the Great Pyramid of Giza. So we used a march in measurements either for us, we were using feet instead of using cubits. So if we go back, we're talking about a pyramid. This is rectangular pyramid. That just means it doesn't have to have a square base, but we can work with that. So we have a pyramid, and we see that volume of a pyramid is 1/3 times length times width times height. Okay, we got to think about what this means here. Height, it's just the height from the top and bottom of your pyramid, or you can do it like this. That height is going to be 481.4 feet. And then what we need is this length. This is my 8. So we need the length and we need the width. Well, because it's a square, length should equal width. And we were told that just one side of the base is 755.75 square feet. Or sorry, not square feet, feet. The whole base is square feet. So here we'll see that volume should just be 1/3 times your length, which is 755.75. Your width, or sorry, I got height. My height, which is 481.4. Then my width, it really doesn't matter which order I do this in. I just want to follow my formula. My width, because length and width should be the same because it's a square base, 755.75. Okay. It's actually in my calculator this time. 755.75 times 481.4 times 755.75. Just double check it. That was a lot of numbers to put in. 1, 2, 3, 1, 2, 3. Okay. So I believe it's 81,651,830.43. It was in feet, and because it's volume, feet cubed. So that's an awful lot of stones to be having there. Well, that's the volume on the inside. There's holes, but we're just talking about the whole volume if we assumed it was filled in. So assuming it was all completely brick in there, and I mean not brick, but stone in there, that's how many cubic feet of stone would be making up that pyramid.